Greetings, YouTube misfits, miscreants, malcontents, and misanthropes. Claire here again after a brief hiatus. Welcome to another episode of Geodesy. Today we're going to talk about the Pacific Northwest, some remarkable volcanoes, and a particularly violent eruption, the memory of which has been passed down to us in the legends and folklore of a native people. The volcanoes I'm referring to are, of course, the Great Cascade Range, a series of volcanoes that represent the most active volcanoes in the contiguous 48 states. Those of us of a certain age remember the following event vividly. For the past few thousand years, Mount St. Helens has by far and away been the most active of the Cascade volcanoes, but such was not always the case. Let's look back on the history of the Cascades a bit. The Pacific Northwest is an agglomeration of microcontinents that were accreted to North America mostly during the Mesozoic era. In the early Cenozoic era, North America began overriding the oceanic Farallon Plate. The remnant of the Farallon Plate, still subducting beneath the Pacific Northwest, is known as the Juan de Fuca Plate. As the plate sinks beneath the continent and deep within the mantle, it begins to melt and magma rises, eventually reaching the surface to create the volcanoes. Much of the volcanic history of the Pacific Northwest has involved extrusion of relatively low viscosity lavas, building up great thicknesses of igneous rocks over many millions of years. Over time, these lavas formed vast shield volcanoes. Shield volcanoes are some of the largest volcanoes on Earth, including some enormous volcanoes like the ones in Hawaii and the volcanoes of Iceland, including the unpronounceable Eyjafjallajökull. Most active volcanoes in the Cascades today are another type of volcano called stratovolcanoes or composite volcanoes, and these feature far more explosive eruptions typically than do shield volcanoes. Composite volcanoes have been the source of many of the world's most violent and deadly volcanic eruptions in human history, including the destruction of Pompeii in 79 AD by the eruption of Mount Vesuvius. One of the most deadly features of eruptions from composite volcanoes are pyroclastic flows. These are rolling clouds of ash, rock, debris, and superheated gases that move at tremendous speed. They can move at over 100 kilometers per hour, and they can be several hundred degrees in temperature. The searing heat within a pyroclastic flow ensures that anyone trapped within such a flow is immediately turned to charcoal, and that's what happened to most of the victims in Pompeii. Another common feature of many volcanic eruptions of this type are lahars. Lahars are massive mud flows made up of meltwater and ash and other mud and debris from the volcanic eruption. And that's a particular problem in the Pacific Northwest, where most of the volcanoes are capped by permanent ice and snow. For example, here is a Mount Rainier hazards map, and the areas in yellow, orange, and red are areas where in the past lahars have flowed. As you can see, they have in the past reached the vicinity of Tacoma, Washington. Another occasional problem with composite volcanoes, and it's one that's often forgotten about, is the problem of edifice failure. In other words, landslides. This is the north face of Mount Rainier. I'll observe the blue arrow. It's pointing to an area of the volcano where a considerable portion of the north face has at some point in the past catastrophically collapsed and slid down into the valley. This is in fact a rather common feature of this type of volcano. It can happen in the absence of an eruption, and if it did happen, it would likely trigger the same sorts of lahars that one sees in an eruption. Earlier, I stated that over the last few thousand years, Mount St. Helens has been probably the most active volcano in the Cascades. That wasn't always the case. Starting about 400,000 years ago and up until about 8,000 years ago, another mountain was probably the most active, and that was Mount Mazama. Mount Mazama lay in southern Oregon, and in its early history, it was far more likely to relatively gently extrude a low viscosity lava than to explode violently. Gradually, over time, however, the magmas extruded at Mount Mazama became more enriched in silica and therefore more viscous. After this time, the eruptions became periodically more violent. Roughly 7,800 years ago, the mountain was racked by a particularly violent eruption. The mountain was entirely obliterated and collapsed into a vast caldera that we now call Crater Lake. The eruption that destroyed Mount Mazama is estimated to have produced about 60 cubic kilometers of ash. By way of comparison, the 1980 eruption of Mount St. Helens produced about 1.2 cubic kilometers. So you see, it's a rather large eruption. Nevertheless, there are larger eruptions in human history. For example, the 1815 eruption of Mount Tambora, which created a year later the year without summer, produced about 160 cubic kilometers of ash. There were human beings around to observe the eruption of Mount Mazama. The ancestors of the Klamath Indians were so impressed by the event, they incorporated it into their folklore. I'm no expert on Indian folklore, but I think the story goes something like this. The underworld god La-O lived deep beneath Mount Mazama, and the sky god Skell lived on top of Mount Shasta. Sometimes La-O would climb to the top of Mount Mazama just to see the stars. And one night from a distance he saw the beautiful daughter of the chief of the Klamath Indians. Well, he immediately fell in love, and he pursued her. But she rejected him because he was very ugly. He got very angry and declared war on the Klamath Indians and started hurling fiery rocks at them. They appealed to Skell for protection, and Skell came in on their side, and in a terrific struggle he destroyed Mount Mazama and buried La-O deep beneath. And just to establish permanent peace and tranquility, he placed a beautiful lake there. Okay then, I'll be back soon with some more geologic history. Bis später.